for those of you who follow me on Twitter, I'm ichnologist. If you don't follow me on Twitter, I'm ichnologist. I was lucky enough to get that handle early on, like in 2010. And as Lewis said, I'm an ichnologist. I study traces, tracks, trails, burrows, nests, and any signs that animals have left of their behavior. What's really cool about what I do is that I can look at modern traces, I can look at fossil traces, and those worlds can blend for me. What's been interesting this summer is we are, of course, in a pandemic. We're stuck at home, wherever home might be. Hence, I normally would be going to the Georgia coast right now, but I can't. So I thought I would bring the Georgia coast to you as well. But I also, for those of you who live here in Atlanta, want to talk about how you can use these ichnological skills then in right here in Atlanta or wherever your home might be for those of you outside of Atlanta. So let's go on to the next slide, please. So let's say you're in Atlanta or the Georgia coast. I know you can't answer right now, but which of these are cat tracks? Which of these are alligator tracks? See, even if you don't know all that much about alligators or cats, I'll bet you can tell the difference, which means already you're starting to become an ichnologist. So with this talk, I want to give you some of those skills of how to spot tracks and other traces, which it's really easy to do this on the Georgia coast, where you have lots of sand and mud and bones and other stuff that holds traces. Here in Atlanta, you go, oh gosh, there's cement everywhere, there's concrete, there are buildings, yet there are still traces. There are still traces out there that you can see them. Okay, next slide, please. In fact, you can look at traces while riding your bike. So this picture of me, very happy, very exuberant, is on Jekyll Island, where I'm riding my bike down the coast, and Ruth Schowalter took the picture. So my wife and I were taking a bike ride out on Jekyll Island on the beach during Thanksgiving break some years ago. While we are riding our bikes, we're seeing traces. Next slide, please. And we see among these traces, these groupings of little clams. These are dwarf surf clams. These clams were congregating, as you can see, in these patches. So all down the beach, we saw these patches of small clams. They were congregating around some other burrower. Next slide. And that burrower was a whelk. Whelks are these really big marine snails. At low tide on the Georgia coast, at low tide, they will bury themselves because they don't want to be out in the open to get eaten by, say, a seagull. They also don't want to be desiccated by being exposed out on the surface, so they bury themselves. But what was interesting here was that all of these dwarf surf clams were also burying themselves around the whelk. Why? Next slide. Here's what happened. The whelks, as they were burying themselves, as you can see on the left, here's one caught in action, burying itself. It was liquefying the sand around it. As it was liquefying the sand, that made it easier for these much smaller dwarf surf clams to be able to burrow in their wake. So they were trying to protect themselves too at low tide. The whelk made it easier for them to do that. Next slide. So really what was happening was the dwarf surf clams were concentrating around the whelks because the whelks were making kind of a quicksand around themselves by burying themselves. Next slide. So the whelk burrowing, that liquefied the nearby sand. That made it easier then for the dwarf surf clams to burrow themselves. So localized quicksand, which we all feared when we were kids, right? But it actually is pretty darn rare, except for whelks and dwarf surf clams, which make it easy. Next slide. So here's the sequence. Next slide. going from liquefying as it's burrowing to the clams are burrowing them. Oh, wait, the third picture. Some of the dwarf surf clams are missing, and there are tracks all around where their bodies were. Who could have done this? Next slide. Yes, that's right. The sanderling, the tyrannosaur of the tidal flat, chowing down on dwarf surf clams wherever it finds it. 28 grams of pure avian fury. Next, please. Yes, that's right. So here's the neat thing. Sanderlings are also ichnologists. They recognize these patterns, these big patches of dwarf surf clams. They go, whoa, free clams, all you can eat. And they chow down on them whenever they find these patches. So what happened was the whelks were actually, they were making it easier for the dwarf surf clams to hide themselves, but they also unwittingly help then the sanderlings find them easier. Next slide. What's neat about this is it also set up this complex food web for the gulls. So here's a laughing gull. The laughing gull would also see some of the outlines of where the whelks were located. They would come in, they would pluck out the whelks. Then the sanderlings would come to where the whelks were, and they would chow down on the amphipods. These were little crustaceans that were just beneath the sand of the whelk. So in every case, the whelks, in trying to save themselves, were actually helping predators of both the dwarf surf clams and the amphipods, the little crustaceans. All through traces, we were able to observe this happening. So that's the power of traces, is that you can actually reconstruct what was happening in the complex food webs of that shoreline, all during a bicycle ride on a nice morning on Jekyll. Next, please. So with the Georgia coast, what happens is sometimes you can be looking onto a landscape, and actually that landscape is completely made up of traces. When I look at this beautiful salt marsh, for instance, with this meandering tidal channel through it, and I see the maritime forest, I know that those landscapes are filled with traces. This is something that I want you to think about if you ever go to the Georgia coast or any other landscape. How many traces are actually hidden in that landscape, whether those are burrows or feces or shells with marks in them left by animals. All of these landscapes contain traces. Next, please. And with these traces, I want you to think with salt marshes in particular, how you have oysters on the left-hand side. You have oysters there. The oysters are actually they are sucking in water. The water contains clays. They're digesting the organics and separating, filtering out the organics from the water. And then, like many things, they poop. So that poop, along with the mussels, they are then pumping out mud, and the mud is packaged as sand grain-sized particles. So they are actually depositing mud in those marshes. That means when you look at a marsh, you are looking at a landscape of traces. On the right, we have fiddler crabs. The fiddler crabs are processing the sediment too. They are rolling up the sediment into balls. They are chowing down on that sediment and then setting it down, kind of like a chicken wing. Then they leave that on the landscape. So they poop as well. All of those are these cumulative traces that are being left in a marsh or some of the landscapes that are around those marshes. Next, please. So when you look from this drone aerial view of Sapelo Island, when you look at a marsh from the air, think again of that landscape as being filled with traces. That if you say, well, I don't see any traces, well, open your eyes and you will see them. Next. A cool thing on Sapelo, if you ever go to Sapelo Island, if you go to the north end of Sapelo Island, a really cool thing that's preserved there is a relict marsh. It's a marsh that's about 500 years old, where the smooth cordgrass that used to live in it, now you just see these brown stubs. So there I am walking across that that part of the shore, and you see this old marsh that's getting exposed where the mud has been compacted, so you can stand on that marshy surface and you won't sink in like you would with an ordinary older marsh. Next slide. This marsh, you can see an extant, a modern marsh on the left with a tidal channel that has oysters in it. There are clams in the middle of that. You have the living Spartina on either side of that tidal creek. Look on the right, where the sand has filled in the old channels. That actually is kind of a pre-fossilized channel. So think about that channel then that originally had oysters, clams, fiddler crabs, and other types of animals that were living in that with the Spartina then on the banks on either side of that. That is all preserved in this Relict Marsh on Sapelo Island. Next. A neat thing you can see sometimes if you go there, there's modern Spartina growing in the old marsh. So you actually have a mixing of 500-year-old marsh that's dead. And so you have the roots there. And then you have new roots of the living Spartina, smooth cordgrass, mixing itself with the old. Now, this would really mess with the minds of a geologist or paleontologist. If I were looking at this in the fossil record, I saw those root traces next to one another, I would assume they were all from the same living community, and I would be wrong. So this, I want you to appreciate also that this is one of the challenges that paleontologists and geologists face when we look at something in the rock record and we say, were these all living together at the same time? In this case, the answer is no. Next, please. This is one of my favorite traces to find on the Georgia coast. If you look on the sandy areas around the dunes, just at the top part of the beach or on the dunes, you're going to see these sets of 8 tracks. There's 4 on one side, 4 on the other, and you can count them 1, 2, 3, 4, 1, 2, 3, 4. This is an animal with 8 walking legs. So 8 walking legs narrows it down, not an insect, and you might say, spider? That would be a really big spider. No, no, it's not. So next slide. Here's another clue. So there are tracks that you see, the tracks off to the left going back and forth, but you also see a burrow, this big sand mound of where this animal dug out its burrow. Next slide. This is one of my favorite animals on the Georgia coast. It leaves such a variety of traces, and it lives between the dunes and the shoreline. This is the Atlantic ghost crab. So you see the ghost crab hunkering down in the sand by the surf there. In this instance, I caught this ghost crab actually rehydrating. It was really thirsty, ran down to the shoreline, and it sucked up water then through its gills, which are on the bottom of its body. But it also lives on the land, so it has little lungs and little gills. It's actually one of these animals that lives between those two environments. So you could call it a transitional animal. Actually lives between those two environments. The trace on the left then is where one of those crabs sat down in the surf. It washed away its tracks leading to that trace. But then once it quenched its thirst, it got up and walked away. When I first found these traces, I was like, what are these? And my wife did the same thing. What is this? One of the most important questions you can ask in science. And from that, we were able to finally figure out and deduce that that's what was happening. About a month later, I actually witnessed this crab doing this. Next slide, please. So here's the crab close up, sitting down on the surf. And next slide. That's the trace it would leave. So if you see anything like this on the Georgia coast, this ghostly trace left by a ghost crab, that's what it was doing. It was thirsty. Next, please. Now, you might look carefully in some of the sand flats at low tide and some of the rippled areas, and you might see this teensy weensy little trail. It's going to be less than the width of your fingernail. At the end of that trail, next slide, at the end of that trail is a teeny weeny tiny horseshoe crab. There are baby horseshoe crabs. I know they sound so cute. Baby horseshoe crabs that are now burrowing and living on the shoreline right now because mating season was in May. From the mating, then you had fertilized eggs, the eggs hatched, and baby horseshoe crabs are crawling around and burrowing right now. On the right, you see a juvenile. It's grown up a little bit. This one could have fit in the palm of my hand. So they were leaving totally different traces as a result. Next slide. Then the full-grown adults, this picture was taken in May of about 6 or 7 years ago. This is where a horseshoe crab got stuck at high tide, and it was stuck on its back. They have these long pointy tails called a telson, and the tail in this case is used to right itself, to try to flip itself back over, because sometimes the waves knock them onto their backs. So Robert Kelly Vance took these pictures for me of where he had this horseshoe crab stuck on its back. It left this series of traces, and he actually helped it. He picked it up, set it down, and then it made these spiral trackways going back to the shore where he was trying to get back into the water. So next slide, where you see the red arrow, that's the horseshoe crab that he saved. If you look down closer to the surf, you'll actually see some of those other dark dots there are from horseshoe crabs as well. Next, please. This is one of my favorite traces to find. When you find on the right side, you'll find one of these perfectly round holes. And it's this beveled hole that you'll find in the side of a clam or a snail. That is the calling card of the deadly moon snail. The moon snail is on the left. I'm holding up a living one on the left. Yes, they are cannibals. So if you see one of these drill holes, that's what this is, a drill hole in the side of a moon snail or a clam, that is a predation trace. That is where a moon snail grabbed onto a clam or snail, engulfed it, and then used this internal tool called a radula, kind of like an internal file, and filed into it, inserted its body, and then chowed down while the animal was alive. Yes, that's why it's one of my favorites. Okay, next slide. You go up into the dunes then, get away from the shore, get into the dunes. Then you're going to see some of these little burrows. They look like a little half moon. If you wait, and they're probably down there right now. This was on Tybee Island. If you wait, you will see the trace maker. This is a wasp, and it's a sand wasp, a genus Stictia, making this. This is a mother wasp making a burrow where it then paralyzes probably a fly. Will bring it back to the burrow, stuffs the burrow with that paralyzed prey, lays eggs on it, and it's a good mother wasp. The eggs lay fresh food for the larvae. Yum! What's cool is looking on the right, we know this has been happening for at least 75 million years. On the right is a trace fossil from the Cretaceous to Medicine Formation of Montana, of where a solitary wasp did probably exactly the same behavior then. So that's a cool thing to think about then, is how we scientists, we paleontologists, ichnologists, can take those modern examples and relate them to what we see in the fossil record. Next slide, please. Now we're on to vertebrates. Here's a mystery trace that my friend Gail Bishop, who was doing sea turtle monitoring on the Georgia coast. He took this picture, I think about 8 or 9 years ago. This is of a, well, you can identify it. Next slide. Yeah, so the red arrows is showing the direction of movement. You can see that there are actually feet in front that are pointing in, and then there are feet in the back that are also kind of pointing in, but also forward. count the toes, and you see it's a hop pattern. As soon as I say hop, now you can narrow it down. This is from a toad, and it's probably from a southern toad, which sometimes they come down to the upper parts of beaches or in the dunes. They're looking for insects or other small prey to snatch up. So it's not that unusual for them to be there. This is a very interesting series of traces left by the southern toad. Next, please. This southern toad, well, it didn't just go hopping. It actually hopped up and then it had to go to the bathroom. And it went to the bathroom multiple times. Next slide. I have helpfully labeled it for you. So it's bounding up to there. It actually turned around. It dragged its butt across the sand. So stopped, backed up, pooped. Then it went forward a little bit, peed once. Then it went forward a little bit more, did some alternate walking, which toads actually do that. And it peed again. So you could say it did number one twice. So number one, then a number one, but number two was done first. So I won't get into the math of it, far too complicated. I didn't want to include math, but there you go. Next slide. Oh, now we are a considerably larger animal. The scale there is in centimeters. This is a much bigger animal. This is from an alligator. And if you look at the trackway on the left, you're looking at the left side tracks, you're also seeing the tail drag. On the right, this was on St. Catherine's Island. My wife Ruth was with me. I had a student, Meredith Witten, who was with me. The three of us, as we were walking along, we see the trackway. We came back an hour later, and the trackway was almost gone. Fiddler crabs had actually burrowed into the tracks and had made their little feeding balls fill in the tracks, almost erased the trackway just within a few hours. So I refer to this in my book as erasing the tracks of a monster, that this can happen so quickly as a result of fiddler crabs burrowing in this upper part of the beach and close to a salt marsh. Next, please. This also happens on the beaches. So this picture that Ruth took of me squatting next to an alligator trackway, where the alligators go out, sometimes they like seafood. So they go out into the surf looking for fish. And when they are coming back, going back to their freshwater pond, they will walk up the beach and leave these tracks. So there's a really nice fresh trackway there on the left. If you look on the right, ghost crabs, in this case, have almost erased the trackway by just walking through those low-lying areas along the beach. They have also started obscuring the alligator tracks there. Next, please. Now we're on to birds, and these are among my favorite traces I ever find on the Georgia coast. The ones on the left are of a bird landing on the beach. You see those really long scrape marks, and the ones in the back, those are scrape marks from their rear toes where they have claws on all four toes. So they have three toes facing forward, one toe facing backwards. This was from a great egret, big white wading bird that it landed on this beach on Jekyll Island. On the right, that is a landing track from a Cretaceous bird in Australia about 105 million years ago. What was really neat about this for me as a paleontologist is because I had seen hundreds of those egret tracks like that on the left and other birds, shorebirds, wading birds that had landed on Georgia beaches, I more easily was able to interpret the fossil track that's on the right. So I know that that bird could fly and it came in for a landing 105 million years ago. So I have the Georgia coast birds to thank for that interpretation. Next, please. Yeah, so there's a close-up then of the great egret track so that you can see the comparison between the right foot of a great egret and the right foot of a Cretaceous bird in Australia, how we can make that sort of interpretation. Next, please. These burrows were quite a mystery to me, and this is a really good example of how scientists are wrong a lot. But then we correct ourselves. So science is self-correcting. When my wife Ruth, you can see her there for scale, when we found these burrows along the shoreline of Sapelo back in, I think this was 2003, 2004, we didn't know what made them. I assumed maybe these were from ghost crabs, but they were burrowing horizontally. And boy, was that wrong. Oh my gosh, that was wrong. Boy, was that dumb. Go to the interior of Sapelo and you will see the identical kind of burrow going on, on. And I can just, even though you're all muted, I know some of you are probably screaming, mole, and you would be right. Mole! That is correct. Next slide. So now with that in mind, you have moles going down sometimes the shoreline, but you also have river otters. No river in sight. There's a river otter trotting along the shoreline. This is a wonderful trackway that Ruth and I, we followed this otter trackway. We never saw the otter, but this is on the north shore of Sapelo, Cabretta Beach. We followed that otter for not quite a mile, but at least a couple of kilometers. I mean, well, maybe a kilometer or two. So along the way then, we could see where the otter changed its gait. We could tell where it went into the surf for a swim, where it came out of the surf. This whole story of that otter and how it spent its morning and had a great time. It was, well, how shall I say this? Utterly delightful. Next, please. On the Georgia coast, though, we don't have just these native animals. We have what I call alien invaders. Among them are armadillos. You'll see the armadillo tracks very frequently in the maritime forest. They're on all of the islands now, but they only got there, some of the islands, they only got there maybe in the last 15 to 20 years or so. They traveled up through Mexico. Somehow they evaded Border Patrol. They got into Texas and then spread their way east, helped by people. People helped spread them because they're very cute. And then they ended up not only in Georgia, but actually made it to the Georgia coast. So you will see their tracks, you'll see their burrows, and all sorts of other sign. Next, please. On Sapelo Island, there are feral cattle too. And that is with that picture on the right is with a telephoto. Never ever approach these. They are also cryptic creatures of the night. I almost never see these cattle, but there are wild cattle that have been living for more than 50 years on Sapelo that leave their tracks and other traces throughout the island interior. So they're adding their traces to the suite of traces that you would ordinarily see on those islands. Next, please. Also on one of the islands, Cumberland Island, the famous Cumberland Island wild horses. So this is one of the few islands on the eastern seaboard of the US that has feral horses, wild horses. Assateague Island is another island that has them. They have, of course, affected the landscapes there because horses graze on the grasses there, which changes the dunes. So they leave a much bigger impact on the environment than the armadillos or the cattle. Next, please. The worst of the worst, though, in terms of the alien invaders of the Georgia coast are the feral hogs. Because the feral hogs, they can eat almost anything. They tear up environments everywhere, from the forest interior to the marshes, to the intertidal areas, to the dunes. Consequently, they have a huge impact on the environment. So these pictures I have are from St. Catherine's Island, where they're particularly abundant. On the right, you see some of them flashing their ham hocks as they leave. Next slide. And this is these two pictures are examples of the impacts they have in the back dune meadow areas where they're rooting around for any food that they might find in the back dune meadows. So that's closer to the maritime forest. But then you look in the upper intertidal and then think about all of the sea turtle nest researchers and monitors right now on the Georgia coast who are trying to protect the nest against the feral hogs, because the hogs, once they find these eggs, they will eat every one of them. You could basically say they're acting like pigs. Next slide, please. Okay, picture there on the left. Now we're going to get to human traces. I know some of you were thinking, oh, but what about humans? Oh. Okay, well, I'm like Ace Ventura. I don't do people, but I did include human traces in my new book because human traces also leave interesting impacts on the environment. About 4,500 to 5,000 years ago, Native Americans were living on some of the islands, and they left these shell rings, these huge structures, 100 meters, 50 to 100-meter wide, ring-like to horseshoe-shaped structures that are composed of oyster shells. This is one that we're looking at on Sapelo Island, and this one on Sapelo Island is about 2 meters to 3 meters tall in places, composed of oyster shells. It's a bit of a mystery why the Native Americans made these, but we think that they were circular deposits made around their circular villages, and that oysters are good food. I think it's that simple. Next line, please. Well, here's an example of repurposing, recycling that happened. Fast forward far into the future of these Native Americans, and then the Europeans show up, the Spanish colonizers show up, and they started wiping out and colonizing and otherwise converting some of the natives, the Wali people who lived there, to Christianity. Then when the British took over, the British took over from the French and the Spanish. When they colonized the islands, they brought in enslaved people from Western Africa. Enslaved people then dug out some of these, basically mined these shell rings and used the shells to make this tabby architecture for the buildings and the plantations. So all of this enslaved people labor then went into making every tabby ruin that you see on the Georgia coast. First the shell rings, then made the tabby. Next, please. Other examples of enslavement traces, for lack of a better term. If you go to Savannah and you're walking in the very quaint, beautiful areas of colonial Savannah, you look down, you see rocks. Those rocks aren't from Savannah. Those rocks, many of them came from Europe. So one time while Ruth and I were walking through Savannah, I started taking a close look at these. The one on the upper right, you can see crinoid stems in there. So that is probably a rock from the Carboniferous of Great Britain, is what I'm thinking. The rock on the lower right, that has some fossil burrows in it. I'm betting those are fossil burrows called scolitos. So those are probably from a Cambrian or Ordovician period sandstone, again from Europe, probably from Great Britain. These were ballast stones. Ballast stones were put in the bottoms of the ships to help them with buoyancy control going across the Atlantic. Then they were filled with indigo, cotton, and other produce, again, made by enslaved people, grown and harvested by enslaved people there on the Georgia coast. So think about this as a trace, as a much larger trace than of inhumanity that you might see in Savannah next time you're there. Next, please. Another trace that we're now seeing of humanity on the Georgia coast is of climate change. These are pictures on Ossabaw from when Hurricane Matthew hit the Georgia coast. Hurricanes are becoming now more frequent and more ferocious because of climate change. So they are upending, as you can see here in Ossabaw on the left, upending some of these old live oaks that are no longer live as a result of the hurricane damage, or washing out some of the roads that are in the interior. These are leaving big traces on the Georgia coast that are indirect traces of human alteration of climate. Next slide. This is on Jekyll Island. And on Jekyll, this is on the north end of the island where the maritime forest is now disappearing. So if you've been to Jekyll, you'll see a so-called tree boneyard on the north end of the island. This is because sea level has been rising, and as it has been traveling to the west, it is now taking out that forest, and the sand from the dunes, what used to be left of the dunes, is now being transported over the marshes. So the island is actually moving as a result of the sea level rising. Okay, next. So I have some artwork. This is a joint artwork that Ruth and I did to symbolize this. So we call this Abstractions of a Rising Sea. It's actually not just a weird, cool, psychedelic, oh, wow, man, kind of artwork. Next slide. It's also a scientific hypothesis. So what it shows is, as a geologist would look at this as a vertical sequence, if this were preserved in the fossil record, the Georgia coast, we would say first at the bottom, we're looking at back dune meadows, sea turtle nests, root traces, insect burrows. You go up, sea level has gone up just a little bit. Now we're getting more into the berm. This is the upper part of the beach. So now we're going to have ghost crab burrows, drilled gastropod shells, broken clams that were broken by seagulls. Sea level goes up just a little bit more. Now we're in a sand flat, we're in a runnel, we're in the intertidal zone where the waves and the tides are affecting it daily. Now we're underwater at the top. Underwater, now you have the fully marine animals that are interacting with those environments, leaving their burrows. So now you're seeing ghost shrimp, other types of crustaceans, polychaete worms, clams, and echinoderms that are now leaving their traces in those environments. So these are the traces of climate change. So we can look at traces from the fossil record when there was climate change in the past and use that to predict what we're going to see with the Georgia coast as sea level goes up in the future. Next slide, please. Can you go at tracking in Atlanta? Now that you have these incredible ichnovision skills, these superpowers, yes, you can take these superpowers out into Atlanta. And during the pandemic, Ruth and I, we've been walking around our neighborhood in Decatur, and we've been documenting traces wherever we find them. Look in the sidewalks, you will see tracks. Sometimes people let their cats out and their cats walk across wet cement and they fossilize those tracks. So these are cat tracks from probably somebody's cat that they were letting loose. Or sometimes you can see feral cat tracks too. Ask me later, I can tell you the difference between feral cat and domestic cat tracks. Next, please. You can also see dog tracks. Look for dog tracks and people tracks where the cement hadn't quite set. Once in a while, it's kind of cool. Once in a while, I see these where it was really clear that a person was walking their dog and they walked across the wet cement together. So that's pretty cool when you can find that. But it doesn't necessarily mean when you find the dog tracks and the human tracks here, that was happening. There again have to be certain clues that tell you that. Next, please. This is my favorite. If you go to Thinking Man Tavern, in Decatur, this is like literally about 50 meters away on the sidewalk, just west of Thinking Man Tavern. These are from a mourning dove. And this mourning dove walked across wet cement, left this really long trackway, and has that typical pigeon-toed kind of gait and the size is right, that I can look at that and go, mourning dove, no doubt about it. And I've seen these tracks hundreds of times in the Georgia coast, so I instantly recognize them for what they are. Next, please. Now look at the end. Look at the ends of some of these twigs too. If you look at, this is an Adair part indicator. If you see a bunch of fresh twigs on the ground, this is from an oak tree. These freshly snipped branches, I just revealed, they were freshly snipped. These are traces too. If you look at the ends, you will see a 45-degree angle at the end. That 45-degree angle tells you that was from a squirrel. This is a squirrel snipping off branches that is using then as nesting material. This was in May, I think in May or so. And this is when they were making nests right after mating season. And then they have babies that are in the nest. So a good trace of squirrel behavior in your neighborhood you can look for. Next. Insects leave traces too. These are sunflowers that one of our neighbors had these lovely sunflowers. Look at the leaves. There are traces in the leaves from insects that were chowing down on the leaves. You also have these marginal traces. Sometimes insects were actually biting into the petals of the sunflowers. I don't have pictures of them here, but some of the sunflowers, also nuthatches, which are birds, were landing on these flowers and chowing down on the seeds, pulling out the seeds. Now the leaf on the right, you can actually see leaf mines, where these little caterpillars will go in between the cuticles of the leaf and they'll chow down on that yummy mesoglea, that material that's in the middle of the leaf. Next, please. Okay, and this is kind of one of those poop versus shinola type of questions. Can you tell the difference between an ant nest and earthworm poop? And the answer is, of course you can. On the left, there's the top of an ant nest. See a really fine-grained sandy material that the ants would have pulled out of the soil and then left at the top. On the right, the earthworms have actually digested the material. They actually ingested it. They were deposit feeding. That forms a little pellet. The pellet comes out the other end, and they make these deposits then. What's also kind of neat about this environmentally is the earthworm poop was made after a rain. The ant nest was made long after the rain, after the water had subsided. So you can actually use this sometimes to tell about fluctuations, little fluctuations in the groundwater table in your neighborhood on when were those animals making their traces. And by the way, if you ever get crayfish burrows in your backyard, you really should get flood insurance because that means those crayfish are living in a floodplain. That's where they live. So keep that in mind. No charge for that advice, by the way. Next slide, please. So just to summarize and review, traces tell us stories, and they tell us about the natural and human histories of the Georgia coast. Those stories, those can be from the past, they can be from the present, but we can also use them to predict the future. So when we look at the Georgia coast, we can use traces as a guide to understand what's going to happen with the future with climate change. And with the last point, traces, and I like to think traces and trace fossils show us the intersections between biology and geology. When some people ask me, am I a biologist? Am I a geologist? I can go, yes. And then you can also apply that to everyday life, whether that's here in Atlanta or anywhere else you might live. Traces are everywhere, just look for them. And I think we're getting into the last slide. The last slide is, of course you would like to learn more. So in learning more, you can get my new book. It's called Tracking the Golden Isles, The Natural and Human Histories of the Georgia Coast. And I do urge people to order from your local independent bookstore or ask your local library to get it. And then you can check it out from your library. But it is available through University of Georgia Press. You can order from them directly. Otherwise, I suggest, your local independent bookstore because we want them to stay in business. Okay, and that might be it.